Okay, let's proceed from where we stop. We need to be sure that proper capture is being done. That was why we had to make sure that yes, we have to continue from where we stop here. So now, like I said, now that we have 5 word number 1/2, you can give yourself like 10 examples of this. You can think of 10 examples that you can use here. 10 examples of this. Okay, that's how you learn. That's how you know more about it. You can give yourself 10 examples. It can be 4 whole number 1/3. It can be maybe 7 whole number 1/4, like that. A lot of examples you can give yourself. But in this case now, it's 5 whole number 1/2. And don't forget, this is 5 times 2, which is this 5 times 2. Okay, plus 1, which is this numerator, which is plus 1, divided by this 2, which is it here. So from the word board mass, bracket of 5 times 2, which is 10. 10 plus 1, that is 11 divided by 2. So this is what we call, this is an example of a what? Of a rational numbers. An example of a rational numbers. That's the first example. Look at the second example here, 0.49. So it means that in standard form, we'll still get to that, because those are the part of the simple part in mathematics. In standard form, we can move this 0 2 times. If we move it 2 times, okay, that would determine the number of 0 you will write at the denominator. I'm moving these points 1 2, so it means you will write equals to 49 divided by 100, which is 100. Okay, if you press your calculator, 49 divided by 100, you will get this answer here. You understand me? So that is very simple. We'll still get to that. That's part of one, simple mathematics and calculation that we also have. I move this 0 2 times, 1 2. That will equals to 49 divided by. So that number of points, that number of movements will determine the number of 0 you will write. So we move it 2 times, that's 0 0. So you can also give yourself like 11 examples here. That is what I do. So you can share your examples in the comment section. Okay, you can give me example of rational numbers, like this first one, 5 whole number 1/2. Give me 10 examples of it. My students, they know me very well. Even while I was they know me very well. I could give them like 50 examples. I could give them like 25 examples. I could give them like 10 examples. It means that the more you do examples, the more you learn, and the more you flow with it. You understand? And the more it's easier for you to learn. So that is just part of the skills that you need to adopt when it comes to mathematics. It's very fun. Sincerely, it's very fun. That is why you see that there's nothing like being too serious here. I'm using this pattern because I know it's easier for us to flow with it. So if you look at it, number 2, look at the example of number 3 here. This number 3, you have 0.5. I'm moving this point 1 time, 1, which is same thing as equals to 5/10. So I'm writing only 10 because I moved the point 1 time. So if you use your calculator, 5 here 1, 5 here 2, that is why you are seeing 1/2 here. So if you use your calculator, 1 divided by 2, you will get this, the same thing as answer. This is another example of rational number. Then from number 4, look at number 4. This is 7. Okay, in any calculation, 7 is the same thing as 7 equals to 1. 7 equals to 7/1 rather. So it means that if I press my calculator, 7 divided by 1, that is 7. This one is straightforward. Then another one which is very paramount that we need to note is the square root of 36. We have some numbers that have perfect square. Okay, like square root of 4. Like this now, like I said, you give yourself 11 example of this. Then you also give yourself maybe like 5 example of this, 5 example, extra example. You take your notebook, give your 5 example of this. Then this one, with this example here, perfect square. You have perfect square like 4, like 9. Square root of 4 is 2. Square root of 9 is 3. Okay, square root of 16 is 4. Then at the end of the day, square root of 36 here is equals to. Now before you remove these square roots, here, in SURD is very important. If you remove this square root, it's telling you that it's either plus or minus. Okay, plus or minus. As you are removing it, plus or minus 6/1. Square root of 36 is what? 6. That is 6 times 6 will give me 36. Okay, so I write 6 here over 1. Don't forget 7 equals 7 over 1. That is why we're also having 6 over 1 here. But because of this square root here is translating to plus or minus. That is, it can either be plus 6 over 1 or minus 6 over 1. Very simple. By the time we move further, you understand what I'm trying to say here. So now another part of it is the opposite side is the irrational number, okay, which is the opposite of what we are saying here. So irrational numbers that cannot be written as numerators and denominator. That is what they call irrational number. If you look at it very well, this is numbers that cannot, which is the same thing as the sequence here, that cannot be written as what? Numerator and denominator, or that cannot be written as fractions. That is just simple, straightforward. It cannot be written as fractions at all, which is what we have here. So irrational number, and I give an example here. First example, square root of 2. Okay, if you press your calculator, you see that 1.444. You have numbers without repetition. You will have numbers that will come out that will be long. You have a lot of numbers. That is what they call irrational number. So it means I cannot write. I cannot take this 0, 0, 0. I cannot take this point as many numbers as possible and translate it to rational number. No, that is why they call it irrational numbers. Here you can give example here. You can come here and give 15 examples on your own in the comment section. To give us example of example yourself, irrational numbers. You can just write it there. Then I can see that yes, you are following. Okay. Then we also have number 2. We have square root of 3. Okay. If you press square root of 3 in your calculator, you have a lot of numbers. And another thing, we have constant values, which is pi. I intentionally write this in red, okay, because in pi has a constant value, which is, this is a symbol here, okay, just like an inverted V. You have an inverted V, this is your V, then you have a dot at the top, okay, is equals to 3 points. You have a lot of numbers too, without repetition, okay. That is what we call irrational numbers. Then another one, we have something like a golden ratio. We also have a golden ratio which has value. Now note this is very key. Irrational numbers like square root 2, square root 3, which is what we have above here, square root 2, we have square root 3, okay. So, and we also have square root 7. Like I said, don't forget, give yourself 15 examples of irrational number. This is another one. Square root 7 are called SURDs. You see now, see how we introduce SURDs from the beginning. You see, this is the first, this is the last year, SURDs. So it's telling us that yes, irrational numbers like square root 2, square root 3, square root 7, we have a lot of them. It could be square root 11, yes, square root 11 too, square root 13, you understand, square root we have square root 17, like that. We have a lot of them, are called SURDs. So that is just the introduction of SURDs. Please make sure you give example of what I said. 1 is 10 example of this. I also said something about 11 example of this decimal, 15 example of this in the comment section. Please ensure that you can give example as many as possible. Then in our next in our next part, we'll now be treating what we mean by SURDs. We give example of SURD and we start breaking it down into pieces. We have so many examples to give, and then you follow it. And I believe that if you can follow those examples, those many examples, you will be very good and you won't have any issues, even at GCE level, at SSCE, at NECO level, even at post JAMB level. We also have SURD coming out in JAMB. In fact, if you can write as many examples as possible, you will be able to even solve mathematics by heart without even looking at book at all. I appreciate your time. Okay, please like, comment, share so that people can learn and also get the meaning of all these things I is being breaking down, so that at the end of the day they can also be expertise. If you know you have children that are doing exam, or they are writing exam, or they are almost getting to SS3 or SS2, SS1, it's for them so that they can learn, because it's going to help them better later. Because I personally, I have my BSc in physics in Obafemi Awolowo University, okay, and I did my masters in exploration geophysics, which is in Unilag here, and then it was fantastic for me because right from time I was also able to adapt to what, as at then, my teachers was teaching me, and I also have a lot of examples that I play around with. So I'm trying to give that to you now, so that contributes to the society, contributes to the community, so that people can learn and see how simple mathematics can be. Mathematics is like understanding English. English and mathematics, they go along together. Okay. I don't believe that people will say I understand English, I don't know math. No, math is just like English. If you don't understand English, simple English, then it means you won't be able to interpret this. Look at all this now, numbers, they're all written in English. It's just a thing of the mind. It's a thing of mindset. It's your mindset. Shape your mindset. Know that this English will be interpreted. Look at this now, very simple. Numbers that can be written as numerator, they are written in English. So it means I understand English, and I was able to interpret it, and I was able to give example of it. And I also want you to also do the same from your own end. Have fun and ensure that you flow with it, and I'm very sure that you will learn very well.